Good day, everyone. Our topic for today is probability. Now, what is probability? Probability defines the likelihood of occurrence of an event, or simply how likely something is to happen. Now, we use probability whenever we are not sure about the outcome of an event, or we may have to predict whether this event to occur or not occur. Probability is also concerning numerical descriptions and has great applications in games, in business to make probability based predictions, and also probability has extensive applications in this new area of artificial intelligence. The probability of an event is defined to be the ratio of the number of cases favorable to the event. An example is the number of outcomes in the subset of the sample space defining the event to the total number of cases. The actual outcome is considered to be determined by chance. Probability has several meanings in ordinary conversation. Two of these are particularly important for the development and applications of the mathematical theory of probability. Probability represents as relative frequencies for which simple games involving coins, cards, dice, and roulette wheels. Now, the outcome of games of chance cannot be predicted with certainty, although the collective results of a large number of trials display some regularity. Probability is the likelihood of a specific event happening, like winning the lottery or rolling a 6 on a die. Finding probability is easy by using the probability formula, the number of the event divided by the number of outcomes. Now, from this figure, if the first roll of dice occurs an event and that is 1 out of 6, then the 5 outcomes cannot occur. So this is only for the first roll of dice. Now let us proceed to the concept of probability. The first concept is probability as a specific term is a measure of the likelihood that a particular event will occur. Now, if we are certain that an event will occur, its probability is 1 or 100%. Now, if it certainly will not occur, its probability is 0. For example, say we toss a fair coin, one which is just likely to give heads as tails. And it is entirely possible that 6 tosses of coin would give 6 heads or 6 tails, or anything in between. So the relative frequency of heads would vary from 0 to 1. Now let us proceed to the solution. The formula we will use is probability is equal to event over outcomes. To this problem, it gives one head only for 6 tosses. Then the probability is only 0.16 or 16% to the tails. There is also a tendency that the event will occur in 50%. It depends on the result of 6 tosses. But the experiment might well result in relative frequencies from 0 to 1. Now let us proceed to another concept. In an actual situation, we can make a moderate number of trials to give us more useful information. The relative frequency of a particular event, or the proportion of trials giving outcomes that meet certain requirements, will give an estimate of the probability of that event. Now, the larger the number of trials, the more reliable that estimate will be. This is also the empirical or frequency approach to probability. Remember that empirical means based on observation or experience. Now, for example, 260 volts are examined as they are produced. Five of them are found to be defective. Now, on the basis of this information, estimate the probability of defective bolts. Now, we will use the formula of probability that is equal to the event over outcomes. The value of the event occurring is only 5 out of 260 volts. And the 260 volts is the outcomes of an event. Now we will substitute the values to the formula and the result will be equal to 0.019 as the probability of a defective volts. Then if we look into the percentage of defective volts, that is equal to 1.09% of 260 volts. For the next concept, which is a subjective estimate based on a person's experience. For example, company hired two geological engineers to examine the area. Where is the best site to drill? One geological engineer examines extensive geological information on a particular property. He chooses the best site to drill an oil well, and he states that based on his previous experience, he estimates that the probability the well will be successful is 30%. Another experienced geological engineer using the same information might well come to a different estimate. Now, how the company will choose from these two observations? Now, the solution here is that the executives of the company can use this estimate to decide whether to drill the well. They can choose the first geological engineer result or the other one because the probability of this is just only based on the experience of the person. The next concept is the approach of probability can be possible in certain cases. Now, this concept includes various gambling games such as tossing an unbiased coin, drawing a colored ball from several balls, identical except for color, which is put into a bag and thoroughly mixed, throwing an unbiased die, or drawing a card from a well shuffled deck of cards. In each of these cases, we can say before the trial that several possible results are equally likely. This kind of concept has a classical or a priori approach. The phrase a priori comes from Latin words meaning coming from what was known before. In some cases, it can be applied directly in engineering because it is often simple to visualize, so giving a better understanding of probability. Let us try to solve the example. Four nuts with metric threads have been accidentally mixed with 12 nuts. And the 12 nuts is under the US threads. Now, to a person taking nuts from a bucket, all 16 nuts seem to be the same. Now, one nut is chosen randomly. The question is, what is the probability that it will be metric? We will use the formula for the probability that is equal to the event over outcomes. Now, for the nuts with metric heads, it is only 4, while the US thread has 12 units. That's why we have a total threads of 16. So the probability of metric is 4 over 16, or just only 25% of 16 knots. How about this another example? Two fair coins are tossed. Now, what are the probability of getting one head and one tail? We will use again this kind of formula. Now, it has two events, head and tail. If we try one toss for two coins, the probability for the head is 50% for one toss only. Now, there is also a possible outcome of tossing the two coins, and these are head to head, head to tail, tail to head, and tail to tail. The next concept is a certain event is 1, and the probability of an impossible event is 0. It means that there is no probability larger than 1 and less than 0. So this is just between 0 to 1, or so-called an axiom of probability. Now, if there is a chance that we can write down probabilities for all possible results, the sum of all these probabilities must be also equal to 1, and this should be used as a check whenever possible. Let us consider this example. An integer is chosen at random from the first 10 positive integers. Now, find the probability that it is, number 1, an even number, and the second one is the multiple of 3. The sample space is S is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the n is equal to 10. Now let us solve the problem. As we can see, there are even and odd numbers from the sample space. Now let us denote A as the event of choosing an even number, and B for the event of choosing an integer. The number of outcomes for A is 5, while on B is only 3. Now we proceed to the formula for axioms probability. The probability function of event A is equal to the number of outcomes of A divided by several finite sample spaces. Now, the same procedure for the event B. Then the result of A is 0.5 while B is 0.3. For the last concept, the fair odds, or this is an alternative quantity that gives the same information as the probability. The fair odds in favor of a result represent the ratio of the amount which should be bet against that particular result to the amount which should be bet for that result. To give fairness, for example, to make a game fair, for every $2 bet on success, $3 should be bet against it. Then we say that the odds in favor of success are 3 to 2, and the odds against success are 2 to 3. Now, what is the conditional probability of success, or P sub r? Let us use the formula for the conditional probability in terms of success. This equation says that the conditional probability of A given B is the same as the unconditional probability of A. Substitute the value. The odds in favor of success are 3, and the total favors for both failure and success are 5. Therefore, the result is 0.6 as the unconditional probability of A. So that ends our topic for today, and keep safe everyone.